Okay, so we've stored data now on the computer. We see how we can do that, the numbers and text. So what does that mean for us? So the first thing to note is that we we have our rasters and we have our vectors, these data structures for storing data. But we can also divide this up into binary and text. So binary means just zeros and ones. The data is stored in this machine readable, this nice format for the computer, where everything is just a long string of zeros and ones, and it can rapidly interpret these. Maybe it's just numbers straight off, binary numbers, or maybe it's an instruction, a direct instruction saying do this, do that. These are files that are very, very good for the computer to work with. Quick to read, and gets the data in as quickly as it possibly can, hopefully, if it's been well designed. Whereas if we have a text file, ASCII or UTF-8 file, we can read it. We can open that file in a text editor. We can create the file in a text editor and start writing text. And we'll be able to read it and understand it. Unfortunately, the computer has to then do a lot more work in order to start working with that data, to manipulate it, to visualize it, because it needs to first look up what the string of text means. It needs to convert everything. It needs to go not just from ASCII or UTF-8. It needs to make that conversion, obviously, to get the data that's in there, but it also needs to understand what those words mean. Each and every time, so that translation from the text, from the human readable text to the computer readable file takes a bit more time. And generally speaking, what we want to do is store our data as binary files. Whether it's raster or vector, we want to store them as binary files so that the computer can work with them as quickly as possible. The downside of that is that we can't read them. If we try to read them, I will show you an example soon. If we try to read them, it's just nonsense. So let's just quickly look at doing this with rasters. So the first thing we need to do with our raster is we need to remember that our raster is built up with explicit coordinates at one location, and everything else is implicit. What does that mean? It means that we need to tell the computer that this string of data that's coming in, this long stream of numbers that's coming in, are simply cell values or pixel values. So you need to read in the first, well, 1, 2, 3, 4, 5, 6 in this case, stop, start putting the cells out here, stop, jump down a row, and then start putting out the next lot. Okay, so it's done that, and we're creating this grid, but then how big is that grid? How large is that on the Earth's surface? So we need to tell it how big each cell is. We also need to tell it where on Earth it is. So we need coordinates and a coordinate system as well. And then we also need some other things like data type and no data values and stuff like this, so that it knows what is and isn't data. More on that in a minute. But so we need this description of the raster because our location is implicit. We need to know how many rows and cells there are. We need to know where to start counting and then when to stop counting. And then move down to the next row. So this is what a raster file in text format might look like. This is an ArcGrid file. This is a valid text file. And as we can see, the file starts off here with a row of metadata, the number of columns, 10 columns, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Number of rows, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct. Well, that's good. We now know how many rows and how many columns there are, and this is the data, which is actually going to come into the computer just as this long stream. And doesn't know. It's kind of implicit in the file structure itself here. As we've written the text, we can see that we've placed them out. Strictly speaking, in a lot of formats, we don't even need to do that. We could just have one long string of text with some kind of separator. Here we have a tab separation in between the different columns. this is more for our sake, so that we can actually read it. We can see where the data is. Strictly speaking, even when reading in the text, the computer probably doesn't need that not in all cases. Some of these text formats will require this structure to be explicitly there. Others, it's implicit. We also need some coordinates, and here we have the x coordinate at the lower left corner, the y coordinate at the lower left corner, so down here, and the cell size. How big is each cell? And it says 500. And then we have the no data value, which is a very, very small, or very, the absolute value is very large. It's a very negative number, an unreasonably negative number. This is so negative, way out on far down left on the number line. This can't possibly be part of our standard data range. So it's obviously something else. It's no data, rather than using the 0, say. So what's missing from this metadata? Well, quite a lot. I mean, we don't know what this data actually represents to begin with. I mean, and there's everything else about when was this data collected, who collected it, what is it? But there's even, what does this mean? What cell size 500 millimeters, yards? You know, it's meters. The standard assumption is it's meters. But it's not explicitly there. It doesn't tell us that it's actually meters. This is also in meters. But in which coordinate system? We don't know. It doesn't say. That information is going to have to be stored in a separate file, or in your head. It's not great. This is not a very good metadata, but it's functional to get an image on the screen. So, yeah, we can sort of accept that for now. And then if we do that, if we put this into a GIS, we get out something that looks like this. You can see here the coordinates for the lower left corner down there, and the values here. So you can see that that's our 95, and then it goes down to a 3, which is kind of dark, and then we go slightly brighter again there, and even brighter again. So this is how we build up our raster. This is the text format, a text format. There are far too many GIS and remote sensing formats, both for raster and vector, unnecessarily so. It's ridiculous. It's entirely unnecessary for there to be so many different types, but this is just a historical fact. They're there. Let the computer deal with it. In a lot of decent GIS software will be able to handle most formats. GDAL, which is an open source command line tool, actually incorporated into things like QGIS and even Esri's products, can read many different formats. It's good in that. So let it handle that. And this ArcGrid format is one of the text formats that it can handle for raster. So if we then take that same file, store it as a GeoTIFF, which is what I've done now, and then read that GeoTIFF into a text editor, the text editor says, right, this must be a text file. Okay, and this is stored in, is it UTF-8 maybe? Okay, right. Okay, so I'll take these 4 bytes and I'll translate that as a letter. And then I'll take the next 4 and translate that as a letter. And then I'll take the next 4 and translate that as a letter. But the GeoTIFF format doesn't care about that. It's not formatted. It's not designed to work in that sense. It's not storing letters for us to be able to read. It's storing the information that it finds, or in a manner that it finds efficient for its purpose, and that's to get the geographic and geospatial information stored efficiently on the computer in such a sense that when it reads it into the processor, it can work as quickly as possible. It doesn't care about our ability to be able to read it. And so our text editor program is doing its best to interpret this stream of bits coming in, and it's getting it wrong. It's getting it wrong because that's not what it was intended for. And so if you open up a file and it looks like this, it's a binary file. It's not a text file, it's a binary file in most cases. If you've chosen the wrong encoding, let's say you're opening up a file that is UTF-8 as ASCII, then it will be largely readable, but some characters will be wrong. That's when you know it's a text file just opened up with the wrong text encoding table. But when it's complete nonsense like this, where there's very little, I mean, we can recognize that perhaps, but where it's largely unreadable, well, okay, that's a binary file. You can wonder why this is actually readable. Quite often you will have mixed data in a lot of these files, whereby the header particularly might actually be partially readable in a text editor. Not always. Some of them have clean human readable headers, and then all the data is stored as binary, but that's not all that common.